Okay, in this quick vid, we'll do a quick refresher on isotopes, specifically counting protons and neutrons here, determining mass numbers. So here's my first example, fluorine. We have 3 different isotopes of fluorine found in nature. How many of each type of subatomic particle are present? We have fluorine 19, we have fluorine 20, and we have fluorine 21. Notice they're all fluorine. The only thing that's different between them is this number, which is the mass number. That's this number right here. Okay, so when it says mass number, we can say fluorine 19 has a mass number of 19. Fluorine 20 has a mass number of 20. And then fluorine 21 has a mass number of 21. You guessed it. There you go. Protons is another easy one to find here because we know since it's fluorine 19, fluorine has the same atomic number no matter where you find it or what isotope you find of it. So, since the atomic number is the number of protons, we can say that fluorine 19 has 9 protons because that is the atomic number. And I'm going to write atomic number up here. That way we kind of remember what that is. Atomic number is the number of protons. So if fluorine 19 has 9 protons, well then fluorine 20 has 9 protons. They're both fluorine. And if fluorine 20 has 9 protons, then fluorine 21 has 9 protons as well. Which brings us to our last column here, number of neutrons. This is going to be the one that we'll have to do some math for. Well, we know our 19 is our mass number. And one good definition that I want to write over here, just so we make sure that we have this, mass number is equal to protons plus neutrons. This is something that we'll need here to fill in this last column. So basically what I'm saying is whatever the number of protons are plus the number of neutrons is going to be equal to the mass number. Or in other words, 19 for our mass number, subtract out the number of protons, and you're left with the number of neutrons, which would make it 10. 10 in this case. Down here for fluorine 20, you have 20 as a mass number, 20 protons and neutrons. Subtract out the 9 protons, and you're left with 11 neutrons here. And then for fluorine 21, you have 21 protons and neutrons. 9 of them are protons, which means you're left with 12 neutrons. Okay, so apply this logic down here for 365. We have strontium 90, mercury 201, uranium 238, and krypton 81. Mass number, protons and neutrons together, the amount of protons, which is the atomic number, like we've been talking about, and then finally the number of neutrons.